In my opinion, the risks outweigh the benefits when using nuclear energy, such as CANUD. Later, I will explain further the risks and benefits for this new type of energy. But first, we must understand how it works. Natural uranium consists of three major isotopes: uranium-238, uranium-235, and uranium-234. All three are radioactive, emitting alpha particles. The common isotope, U-235, is the one used to generate electricity because it can easily undergo fission. A half-life is the time taken for the radioactivity of a specific isotope to fall to half of its original value. The half-life of uranium-235 is 703,800,000 years. Uranium is a naturally occurring element in the Earth's crust. To make nuclear fuel from the uranium, ore requires first for the uranium to be extracted from the rock in which it is found, then enriched the uranium-235 isotope before being made into pellets that are loaded into assemblies of nuclear fuel rods. Like most reactors, high-level waste contains Pu-239, Xe-133, and a wide assortment of other isotopes. The coolant has N17CO60 and many other isotopes from corrosion products and the water itself, including tritium H3. Used fuel from each reactor is stored on-site in deep water pools used for cooling and shielding. There are about 2 million used fuel bundles in Canada. Once a few years have passed, the fuel may be moved to above-ground dry storage in concrete canisters, with passive cooling provided by airflow. As with any other sort of natural resource mining, the process of removing uranium from the earth can be damaging to the environment on both a short-term and long-term basis. Most people are familiar with the tunnel mining technique used to extract coal. Uranium employs this technique as well as open pit mining and situ leaching, the safest method for miners since it never involves putting humans in direct contact with the radioactive ore. What concerns exist about this mining and processing sources of uranium? So, to prepare the uranium used for a nuclear reactor, it undergoes the steps of mining and milling, conversion, enrichment, and fuel fabrication. These steps make up the front end of the nuclear fuel cycle. After uranium has spent about 3 years in a reactor to produce electricity, the used fuel may undergo a further series of steps, including temporary storage, reprocessing, and recycling before wastes are disposed. Collectively, these steps are known as the back end of the fuel cycle. There are three main kinds of ionizing radiation: alpha particles, which include 2 proteins and 2 nutrients; beta particles, which are essentially high-speed electrons; gamma rays and X-rays, which are pure energy. One example of long-term negative impacts of uranium mining can be witnessed in the small rural community of Deline. So, waste from both radium and uranium mines were dumped directly into the lakes used as landfills. This cost a high price in environmental and health effects. No warnings were issued, so no one took precautions regarding their drinking water or their traditional foods. Young men from Deline were sent to work in the tunnels on a government training program without masks for radon gas exposure to clean up hotspots of radioactive soil in Sawmill Bay without shower or decontamination facilities. Many men that worked in the mines have died of certain forms of cancer. The Nadines First Nations now live in constant fear of their contaminated land, water, and animals, with ongoing concern about their health and survival. And no justice was brought to the Dene First Nations. There are 3 main types of ionizing radiation. So, alpha particles, which include protons and 2 neutrons; beta particles, which are essentially high-speed electrons; gamma rays and X-rays, which are pure energy, photons. Water subjected to ionizing radiation forms free radicals of hydrogen and hydroxyl, which can recombine to form gaseous hydrogen, oxygen, hydrogen peroxide, hydraulic radicals, and peroxide radicals. In humans, it can cause oxidative stress, accumulative damage, which may be significant enough to cause cell death or may cause DNA damage, possibly leading to cancer. In cooling systems of nuclear reaction, the formation of free oxygen would promote corrosion, and it's counteracted by addition of hydrogen to the cooling water. Why is there concern about changes to matter as a result of exposure to ionizing radiation? Well, when ionizing radiation passes through matter, energy is deposited in the material concerned. Alpha and beta particles, being electrically charged, deposit energy through electrical interactions with electrons in the material. Gamma rays and X-rays lose energy in a variety of ways, but each involves liberating atomic electrons, which then deposit energy through interactions with other electrons. Neutrons also lose energy in various ways. An important means being through collisions with hydrogen nuclei, which are single protons. The protons are set in motion and being charged, they again deposit energy through electrical interactions. So in all cases, these radiations ultimately produce electrical interactions through the material, and this can give rise to ionization, when a neutral atom or molecule becomes charged as a result of a lost electron. The two main reasons why I am against nuclear energy is 1, radiation, and 2, pollution. So radiation. Uranium is the most radioactive element dangerous to humans. Both long-term low levels and short-term high-level exposure can cause sickness, death, and birth defects for generations, as it has been seen following the Hiroshima and Nagasaki blasts at the end of World War II. The raw material mining processes is not as traumatic as those events. Uranium is radioactive even sitting in the ground, creating some risks to miners, as well as the problem of how safety deposed the material from after extraction. Pollution. So uranium mining may be less damaging to the environment than traditional methods of pursuing fossil fuels through both mining and drilling, but it is still a hazard to the newer natural environment. A singular nuclear power plant emits carbon dioxide into the atmosphere, contributing greenhouse gases to the distributed effects of global warming. In addition, large amounts of electricity can be generated from a single plant, requiring less physical space than the sprawling multitude of traditional power plants. In conclusion, the mining process of natural sources of uranium is more harmful to the environment than good. Taking into account the advantages and disadvantages of nuclear reactors, I can clearly state my position against the use of nuclear energy, defending my position through the disadvantages of such actions. Nuclear reactions are not only harmful to the environment, but to the humans dealing with a toxic product. If the waste produced by nuclear reactors isn't disposed off at a safe place, it can be extremely hazardous and can leak radiation. It contaminates sand or water because of the radioactive waste. Even small radiation leaks can cause devastating effects. Some symptoms include nausea, vomiting, diarrhea, and fatigue. People who work at near nuclear power plants and live near those areas are at high risks of facing nuclear radiations. Another practical disadvantage of using nuclear energy is that it needs a lot of investment to set up a nuclear power station. Nuclear energy has given us the power to produce more weapons than to produce things that can make a world a better place to live in. These are the reasons why I am against the use of nuclear energy. Thanks for watching.